The last section we'll look at this year for statistics is confidence intervals. Now, no set of data is perfect when it is collected, and the interpretation of the data is even, there is chances for error in the interpretation. So because of this, surveyors will create what's called a confidence interval, which includes a margin of error so that there is a possibility of error within their survey results, as well as a level of confidence, what's called a confidence level. Now within this problem, what we'll do is we'll look at both of these and interpret these results. So a telephone survey of 600 randomly selected people was conducted in an urban area. The survey determined that 76% of people from 18 to 34 years of age have a social networking account. The results are accurate within plus or minus 4 percentage points 19 times out of 20. So if we look at this, this is what's referred to as the margin of error, the plus or minus percentage points. So in this problem, the margin of error is plus or minus 4 percentage points. So again, what this is saying is these results could vary from 76%, 4 percentage points above and 4 percentage points below this percentage that they're given here. And I'll show you how this confidence interval will work after. The confidence level is this, the 19 times out of 20. So the confidence level just tells us how sure the surveyors are of their data. So the confidence level is 19 times out of 20, which realistically this is, we'll write this as a fraction, 19 out of 20, and if we multiply it by 100, will give us a percent, 95%. So the confidence level is 95%. Again, this is saying that these surveyors are 95% sure that their data or their confidence level will be correct. So there is still, they're saying there's 5% chance that they're wrong, that the actual population will not be within 4 percentage points of this 76%. There's still that 5%, but they're 95% sure if the total population was surveyed, it's going to fall between this confidence interval that's created with the average and this margin of error. So this is what the confidence interval actually looks like. The confidence interval itself is this. It's 76% since this is their results that they've decided, or their average or whatever it is, and they are saying it's correct within 4 percentage points, so plus or minus 4%. So when we look at this, what this means is it's 76% subtract 4%. Actually, I won't write the equals here. This means 76% minus the 4%, which is 72%. And it's also 76% plus the 4%, which is 80%. So this is realistically, the confidence interval is this. It is 72% to 80%. So what these surveyors have determined is that for all people in this area, wherever they're representing this sample, so they only took 600 people. This wouldn't even represent the size of our school. So it would be difficult to survey everybody in a community or a city. So surveyors take a small sample and they conduct their survey. So this survey says that the people between 18 to 34 years of age that have a social networking account is going to work out to be about 72 to 80% of the people within this community. And they're 95% sure that the percent of people within that community are going to have, between these ages, are going to have a social networking account, 72 to 80%. So the question actually asks us, calculate the range of people that have a social networking account. We're not just looking at the percentage, we're looking at how many. So 600 people were surveyed. All right, and so what we would do is 600 multiplied by the lower end of this confidence interval, which is 0.72. This will give us 432. And then 600 times the upper percentage, which is 80%, is 480. So the confidence the confidence interval for the actual range of people, the number of people, is 432 to 480 people who are 18 to 34. Have a social networking account. Now, if we look at a second example, which includes an actual table, so this would be a realistic table representing Canadian surveyors, Ecos, Nanos, Ipsos. So these companies do polling for like in Canada, and this would be an example of one for an election or a lead up to an election. So November 2010, here are the results. Here's the Conservative, the percent of people that they surveyed that would vote for the Conservatives. Here's the percent at that time who were going to vote for Liberals, the NDP, Bloc Québécois, Green Party, and other. So in terms of this, they show the sample size that they surveyed. Ecos did survey more. They surveyed 1,815 as compared to the other two. It's higher. And if you also notice that their margin of error is lower than the others. So this question asks, how does the sample size used in a poll affect the margin of error in the reported results? Well, this would be realistic for most. So the larger the sample size, the smaller the margin of error will be. And this should make sense. I mean, if you've done surveys in school, some have for some classes, you would find like if you only surveyed 1 or 2 people, your results aren't going to be as accurate as if you surveyed 200 to 300 or even 500 people. So the more people you survey, the better chance you have of getting more accurate results. So the larger the sample size, the smaller the margin of error. So let's look at the confidence interval in the reported results. So we're not looking at the number of people, we're just looking at the confidence intervals here. So we are going to use the percent that's given. I'm going to use the Liberal Party since they're the party who is the minority government now. So I'm going to use their results. So for the Ecos survey, what this is, I'm going to take the percent. So 29% of people said that they were going to vote Liberal at this time in November 2010. Now the margin of error is plus 2 or 3%. So this confidence interval, what Ecos is really saying is that for this confidence interval, we would take 29 and we would subtract 2.3%. which would give us 26.7%. And then we would also take 29 and we would add 2.3%, which would give us 31.3%. So what they're saying is their results say it's 29%, but they also know they really haven't surveyed enough of Canadians to know for sure. So they are creating a margin of error saying, look, it's going to fall between these two spots. We're pretty sure. Because it doesn't actually give the actual, it says the confidence level is 95% for each of these. So their confidence level is really 26.7% to 31.3%. So in this moment, they're saying 29% of the population is going to vote Liberal, but that could change. Things could happen. They're saying it's very likely that it's still, no matter what happens later on, that 26.7% of Canadians to 31.3% of Canadians are going to vote for the Liberal Party at the election time. For the Nanos survey, they're saying 32% of the population is going to vote for Liberal. But their margin of error is greater, so it's a plus or minus 3.4%. Again, because they surveyed less people. So the concept with this, when we're creating the confidence interval, is we would take 32 and subtract 3.4, which would give a percent, which would give us 28.6%. And then we would take 32 and we would add 3.4 percentage points, and that would be 35.4. So their confidence interval for these reported results is that 28.6% to 35.4% of Canadians are going to vote for the Liberal Party. Now, it's a little higher than ECOS, but again, you would have to decide which you would feel is more accurate. Again, the margin of error is small. They surveyed a higher amount of people, more than double what Nanos surveyed. So, but there is some gap of where there would be some overlap in these. The last one is Ipsos. So they said 29% of Canadians are going to vote for the Liberals, with their margin of error being plus or minus 3.1%. So 29 minus 3.1% is 25.9, and 29 plus 3.1% is 32.1%. So their confidence interval is this. It's 25.9 to 31.2%. So these are how you write the confidence intervals for each. Again, it is a way of safeguarding against error that would be in a survey. I hope this helps.